All right, Nines, I got a request for the thinking question from the practice test number 2. So let's have a read of the question. So at 12:30, Simon leaves town driving at 80 kilometers an hour. And then there actually should have been the comma there. And then at 1 o'clock, Elias leaves town along the same highway driving at 100 kilometers an hour. And so we want to know at what time Elias catches up with Simon. And we've been told that we have to solve a system of equations for full marks. So first you look for the actual question. And so our question is, at what time did Elias catch up with Simon? So if you take a look at this question, it's going to give you the variables because what you're trying to find usually is in the question. So we want to find out the time, and then actually that's all we want to find out here is at the time, but then it also talks about catching up with Simon, so that's the distance covered. So we're going to let x represent the time. And then we need to tell it what the measure is. And so in this case, we're going to measure it in hours. So time in hours, right? We need, it could be minutes, days, but we're going to do hours. And then we need to take a look at our question here. And our question says that Simon leaves at 12:30 and Elias leaves at 1. So we actually, normally when you start counting time, you start from now. And we need to know when now is. So when do we actually want to start counting this? So we want to start counting this at either 12:30 or 1 o'clock, and then we can see how many hours it takes. So either works, you can do either, but what I like to do is to do the later one because it just makes the equations a little easier to solve. So I'm going to say let x represent the time in hours beginning at 1 o'clock p.m. All right, so then y, as we know, is going to represent the distance. So let y represent the distance, and it's the distance from town, right? So we always want to be specific in our variables, and that's going to be measured in kilometers, right? Because they're driving at kilometers per hour. Okay, so, and again, if you're stuck on what your units are, if you take a look at your at the slope equation, right? It's talking about kilometers per hour. So it's best to represent the time in hours and the distance in kilometers. So now we need to look at here. It says you must solve a system of equations for full marks. Okay, so we need to do that here. So that means we have to set up a system of equations. And as you know, equations, a system is 2 or more different equations. So let's start. So I'm going to actually look at Elias first, because Elias leaves at 1 o'clock, so he's leaving right now. So if we quickly take a look at that, then we know that for him, so Elias, his distance covered is going to equal 100x. And the reason I know that is distance is equal to speed times time. So in this case, distance is represented by y, speed is represented by the 100 kilometers an hour, and time is represented by x. So now I need to set up Simon's equation. Well, again, distance is represented by speed times time. So y is going to equal 80x. But now I need to figure out what my y-intercept is. Well, for Elias, my y-intercept was just 0 because he starts at 1 o'clock, so he's starting right at town. Okay, so at 1 o'clock, he's just leaving town, so he has a y-intercept of 0. Simon, on the other hand, at 1 o'clock, he's been driving for half an hour. So Simon has been driving for half an hour. So he's already he's already partway out of town. Okay, so he's already been driving for a half an hour, right? He left at 12:30. By 1 o'clock, he's been driving for half an hour. Well, we know that to figure out where he's at, distance is equal to speed times time. So we know that y is going to equal 80 times a half. So after half an hour, or by 1 o'clock, he's already 40 kilometers away. So that means that we have to add 40 to his equation. Okay, so because at 1 o'clock he's 40 kilometers from town. So his speed times his time plus where he's at. And now we have a system that we can solve. So let's go ahead and do that. So we know that when we're solving a system of equation, y equals y. So we have 100x is equal to 80x plus 40. So I'm going to subtract 80x from both sides. So I get 20x is equal to 40. So now I'm going to divide both sides by 20, and so x equals 2 hours. Now, let's quickly go, so it doesn't ask us at what distance, right? If we go back to the equation, it just says at what time did he catch up with Simon. Whoops, it just says at what time did he catch up with Simon. So I'm not going to do any more work here because I don't need to know what the y is. But what I do need to do, though, is recognize that this is hours, and it's asking me about time. So since x represents the time in hours beginning at 1 o'clock, right? After 2 hours, so after 2 hours, the time is going to be 3 o'clock because it's going to be 1 p.m. plus 2 hours, which is going to be 3 p.m. Okay, so when you write your concluding statement, you're going to say, therefore, Elias caught up with Simon at 3 p.m.